Hello, this is Attila Gabriel Branietsky of Bluish Green Productions. I'm here to show you how you can extend some of the projects from the Udemy course entitled Learn to Code Making Games Complete C# Unity Developer 2.0. In this video, we'll be adding to Project Boost. Here's our goal this session. We're going to create a simple camera that follows the player as they progress through the level, making it both so that the player can't see the entire level and so that you have a greater level of detail that makes it easier to navigate the play space. So, what are our options for adding the camera follow to the rocket ship? The first and most obvious option we have is to child the camera to the rocket. So let's give that a try. Open up Unity, and we're going to grab the main camera, which, as you can see, I've zoomed in on just this small section of the game. If you right now have it where the camera can see the entire level, what you want to do is zoom in and get the view looking exactly like you want it in the scene view, like this. So I want the player to see about this much of my level. And then you can, with the main camera highlighted in the hierarchy, you can select Game Object, Align with View, and you can see the camera preview will now show you what you can, preview of the game window. So with that done, let's try dragging the main camera as a child of the rocket ship and run the game. So at first it looks like we've got what we wanted, except when we start rotating the rocket ship, you can see the main camera is inheriting the rotation information and making this way harder than it needs to be, and a little sickening when you die. So that's obviously not a great solution here, because the main camera is inheriting the transform information of the rocket ship as it moves. So let's unchild that, put the main camera back up here in the hierarchy, and let's look at our second option, which is to make the camera follow the rocket ship via a script. So how do we do that? Well, actually, you're going to get things started here with a challenge. Pause the video and try the following steps. Add a C# script component to the camera called cameraFollow. Expose a variable of type transform to the inspector called targetFollow, and then link the rocket to the camera in the inspector. Once you've done that, you can unpause the video and I'll show you how it's done. Alright, so hopefully you've given that a try. So, following along step by step, we're going to add a component here, select at the very bottom, new script, and we're going to call this cameraFollow, create and add, and wait for that to double-click to open it in your editor of choice. I'm using Visual Studio Code, so your coloration might look different from mine, but that doesn't matter. First thing we need to do is have a variable that's exposed in the inspector. We'll do that with a serialized field, and is of type transform. There we go, and it's called targetFollow. Okay, just like that. Save your script. You can tell it's saved because this will turn into an X instead of a circle. Back over in Unity, this should update, and you can now see it's expecting a transform here, which we're going to give it by selecting the rocket ship and dragging that on to targetFollow. So if you have trouble with that, if you end up clicking away to the rocket ship and it disappears, with the main camera highlighted, you can click this lock in the top corner and the inspector will lock. Then you should be able to select the rocket ship and drag it over with ease, and then just make sure you unlock the inspector afterwards. Okay, so are we done? Well, not quite. When we try to run the game, obviously nothing happens yet, but at least the camera doesn't have any sickening rotational information. So let's take a look. What is next? Well, we need to make the camera update its position to match the rocket's position. Okay, so we're going to do that over in Visual Studio in the update section of the script. We're going to make the transform position of the camera. This is its XYZ position. We're going to make that match targetFollow dot position, just like that. Because this is already of type transform, we just need targetFollow dot position. If this were of type game object, then we would have to say targetFollow dot transform dot position. All right, so let's give that a look and try running the game. And once it's compiled, there we go. Well, we are a little too zoomed in. So what's happening now is the camera's position is exactly being set to the rocket's position, which is not what we want. We need an offset. To add an offset, what we have to do is subtract one transform position from the other to give us the difference between those two offsets. In the same way that the difference between 5 and 7 is 2, and the difference between -8 and 4 is -12. What we're interested in is the offset position from one to the other, and then we're going to add the difference, which will hold the camera in place as the rocket moves. All right, so with that information, I'd like you to try another challenge. Add a vector3 variable initial offset to camerafollow.cs. In the start method, subtract the transform of the target from the camera's position. And then the update method, add the initial offset to the camera's position. All right, give that a try. Okay, so hopefully you've given that a shot. What we'll do now is in here, in camera follow right up at the top, this doesn't need to be publicly exposed, so we can make this a private vector3, and I asked you to call it initial offset. Okay, and the initial offset is going to be defined here at the start method to be the difference between the transform positions. So think about what is the actual difference between the two transforms. Well, the transform of the camera is this, transform.position, and the transform of the target is target_follow.position. So the difference between them is basically this, is transform.position minus target_follow.position. Okay, so this will create a vector which keeps track of the physical distance from the camera to the rocket ship. And then here, instead of just setting it the transform position of the camera to exactly the target follow.position, we're just going to say it's the target follow.position minus, we're going to add the offset back onto it now. Why are we adding the offset? Well, let's try subtracting the offset first and run the game. Once it's compiled. Okay, yeah, we ended up looking into space. So back over here, let's change this to adding it. Back over to Unity. Run the game. And there we go. Finally, we have our intended behavior where the camera is following the rocket ship, not too closely, not rotating in line with the rocket ship. We're only updating the camera's X and Y transform position, not also matching its rotation, which makes the level far easier to beat. All right, so that is everything. Thank you for following along, and I hope you learned something. For more advanced camera behavior, check out the tutorials provided by Unity on using Cinemachine, which you can visit by checking out the URL that you can see on screen here, or searching for Unity and Cinemachine tutorials. Thanks a lot for watching. See you next time.